This video covers questions from 2.1 rectangular coordinates and graphs. The first question gives a table of values where you have x's and y's, and the directions are to give 3 ordered pairs from the table. Well, the table actually gives you 5 ordered pairs, and you're asked to select 3 of them. Each pair of numbers here creates a point on a graph. So one point would be 2 comma negative 5. That's 1 point. Notice I took the x and the y from the first of each column. Another point is negative 1 comma 5. Another point is 1 comma negative 4, and so on. We're just asked to give 3, so we have a selection of 3 points here. We group them as a set, so that means we use these little squiggly brackets. We can do it like that. And there are actually a couple more. We just want to give the first 3. In this case, the choice C is the correct choice. I'm going to select that and check the answer. For question number 2, we want to find the distance between these 2 points. To do this, we need to use the distance formula. The distance formula is d equals the square root of x sub 1 minus x sub 2 squared, that quantity, plus y sub 1 minus y sub 2 quantity squared, and take the square root of all of that. I'm plugging in the numbers. I'm using x sub 1 here, that's our negative 5. Negative 5 minus x sub 2, that's going to be our 2. Close parentheses squared. And y sub 1 is 23 minus 26, that quantity squared. Do the order of operations, and what I like to do is simplify what's in the parentheses first. Negative 5 minus 2 is negative 7. And then 23 minus 26 is negative 3. And then we continue to simplify. Negative 7 squared is 49. And negative 3 squared is 9. We add those together. So the distance between those 2 points is square root of 49 plus the square root of 9, which is the square root of 58. Let's check to see if that is our answer. Use the math palette to select the square root. Check your answer. Fantastic. This question has part B where we're asked to find the midpoint. To find the midpoint, we are going to use the formula for midpoint, which is, the midpoint is x sub 1 plus x sub 2 divided by 2. Basically, you're adding up the x values and dividing by 2, and y sub 1 plus y sub 2 divided by 2. You're going to add up the y values and divide by 2. Plugging in the given values, we can find that our midpoint is negative 5 plus 2 all divided by 2, and 23 plus 26 all divided by 2. Simplify the numerator, we get negative 3 over 2. Simplify the numerator, we get 49 over 2. Now I would suggest keeping those as fractions and making sure that you use parentheses to denote the ordered pair that is the midpoint. It's the point right in between those two. And our answer was negative 3 over 2 for the x value and 49 over 2 for the y value. Question number 3, it's asking the same as number 2, where we're asked to find the distance between the 2 points and the coordinates of the midpoint. What we are looking at here is that the points have radicals in them, so we just need to take our time and evaluate this just like before, taking care of those radicals. We're going to take x sub 1, 3 square root of 2, minus x sub 2, which is the square root of 2, that quantity squared, plus y sub 1, 7 square root of 5, minus y sub 2, which is a negative square root of 5, that quantity squared. We're going to simplify what's in the parentheses first, taking the square root of, in the parentheses we have 3 square root of 2, subtract 1 square root of 2, and I get 2 square root of 2, that quantity squared. Next we have the 7 square root of 5 minus a negative, we're going to make that a plus, square root of 5, so we have 7 square root of 5 plus 1 square root of 5 is 8 square root of 5, that quantity squared. We can now simplify by squaring each of these values. 2 square root of 2 squared, that's the same thing as 2 squared, which is 4, and square root of 2 squared, which is 2. It's really 4 times 2, and we get 8. For the second term, when we square it, it's 8 squared times, 8 square root of 5 squared. Alright, so we're squaring 8 square root of 5, so it's really 8 squared, which is 64, times the square root of 5 squared, which is 5. 64 times 5 is 320. Oops, 320. Let's simplify that. The distance is the square root of 8 plus 320, so that is the square root of 328. Oops, made a little mistake here. Square root of 328. Let's check to see if they'll accept this answer. We may need to simplify the radicals. Square root of 328. Check your answer. Okay, it says that it is equal to the correct answer. It's not in the correct form. All right, what that means is we need to simplify this radical. There is another way we can write the square root of 328 by determining if there's any perfect squares. When you try to simplify the square root of 328, you want to try to find a perfect square that goes into 328. The largest perfect square that goes into 328 is 4. 328 is the same thing as 4 times 82. And the square root of 4 is 2, and 82 is not a perfect square, so we're going to write our answer as 3 times the square root of 82. Sorry, 2 times the square root of 82. Check your answer. The second part of this question is to find the midpoint. Using the midpoint formula, I'm going to use the letter M for midpoint. We add the x values, x1 plus x2, divide by 2, add the y values, and divide by 2. The first x value is 3 square root of 2 plus the other x value, square root of 2, divided by 2. Add up the y values, 7 square root of 5 plus a negative square root of 5, all divided by 2. 3 square root of 2 plus another square root of 2 is 4 square root of 2 divided by 2. 7 square root of 5 minus the square root of 5 is 6 square root of 5 divided by 2. We want to simplify this 4 square root of 2 divided by 2 gives you 2 square root of 2. 6 square root of 5 divided by 2 is 3 square root of 5. That's the midpoint between those two original points. We're going to type in the answer using parentheses. Both of the answers involve fractions. Oh, I'm sorry, we simplified those. Let's delete those fractions. 2 square root of 2 for the x value and 3 square root of 5 for the y value. Nice work.